Okay. So the last thing we found the equation of a 3D line. And I told you about the direction vector. The general form of the equation of a 3D line, it is this: r is equals to position vector on the line plus the parameter multiplied by the direction vector of the line. This is the general equation of a 3D line. And we'll do another this example 0, 0, 1, and you have 2, 1, 4. And we if we how do we find this, the equation joining these two 3D points? So position vector is any one of the point, right, with relevant, sorry, what was it, relative to the origin. So the coordinates as well, I told you the coordinates of a point are the same as the position vectors because both of them are relative to the origin. So this means you can use any one of these points as the position vector plus lambda, and this is the direction vector. And how do we find the direction vector? Direction vector is simply, let's suppose this is point A, this is point B. So if you find the vector AB, which will be equal to OB minus OA. So OB, it is 2, 1, 4 minus OA 0, 0, 1, and simplify. So 2, 1, 3. This is your direction vector. That's it. This is it. Equation of a 3D line. You need any 2 points. So you'll find direction vector. You have already the position vector, and this is it. Now the new thing, finding the dot product. Dot. This is also a very simple thing, very easy. Dot product is A dot B, vector A dot vector B. So for example, if your A is 2, 3, 4, and vector B is -7, -2, and 1, how do we find A dot B? A vector dot B vector. So you will write it like this as well: 2, 3, 4, dot in between, and then -7, -2, and 1. And it is easier than the previous thing. You just multiply the x with the x. So 2 times -7 plus multiply the y with the y, 3 times -2 plus multiply the z with the z, 4 times 1, and then you add them all up. So -14, -6, -4. So -14 -6, it is -20, minus plus 4 is -16. This is your dot product. So you multiply the x with the x, the y with the y, and the z with the z, and you add them all up. This is it. So if I write it down, the generalized format: x1, y1, z1 dot x2, y2, z2, it will be equal to x1, x2 plus y1, y2 plus z1, z2. This is it. Simple dot product. Nothing more. And the thing that you would further use this dot product is finding angle between two vectors. So if your vector is something like this and there another vector like this, they may be touching or may not be touching. Okay, it doesn't matter. It's a 3D thing. If you visualize it, your vectors may cross each other or may not cross each other, but they would have an angle between them. This is your theta, the angle between them. And how do you find this? Using this dot product. So A dot B is equals to magnitude of A multiplied by magnitude of B into cos of theta. And theta is the angle between them. So if I use the same question to find the angle between these two vectors. So you have already found the dot product. So the dot product of A dot B, it is minus 16. So minus 16, it is equals to magnitude of A, which will be square root of x square plus y square plus z square. So 2 square, 3 square, 4 square multiplied by square root of the other one, magnitude, minus 7 square, minus 2 square, and 1 square into cos theta. And then you will use your calculator. Use it. So minus 16 upon the square root of 4 plus 9 plus 16 multiplied by square root of 49 plus 4 plus 1. So negative 0.4041, something like 4043 something. And this is equals to cos theta. And so now you will move the cos to the other side. So cos inverse of this answer is 113.8. This is the angle between the two vectors. This is the this is the obtuse angle. If they ask you for the acute angle, you would just subtract it from 180. 180 minus obtuse. So if you subtract it from 180, 180 minus, so this is 66.2. This is the answer. Sometimes they would ask you to find the acute angle between the two vectors. So if your answer is coming out as obtuse, you will just subtract it from 180. This is how you find the angle between two vectors. Copy this down. If you have any questions, ask. You have to learn this formula. Okay. In continuation, this is a very simple formula. In continuation to this thing, they would ask you to find angle between two lines, two 3D lines. So they would give you the two equations of the lines, 3D lines, and you would use the direction vectors. So what would you use? The direction vector of line 1 dot with the direction vector of line 2 is equals to direction vector of line 1 magnitude, direction vector of line 2 magnitude into cos theta. Let's find the question. Look at this question number 10, part B. They have given you the equations of two lines. We know that this is the direction vector, and this is this is your what was the name, position vector on the line, and this is the direction vector of the first line, and this is the direction vector of the second line. So you would take now these two things. So 2 minus 1 3 dot, I'm doing the part B, dot 1 minus 1 4 is equals to magnitude. So square root 2 square is 4, 1 square is 1, 3 square is 9. Square root 1 plus 1 plus 16 into cos theta. And look, they're asking you to find the acute angle. So let's see if it is coming out as acute or not. So for the dot product, 2 times 1 plus minus 1 times minus 1 is 1 plus 12 upon everything on the right side, the square roots, they will go over there and divide. So this is 14 and square root 18. So use a calculator. Cos inverse 2 plus 1 plus 12 upon under root 14 times under root 18. So 19.1. This is coming out as acute. So leave it be. This is your answer. 3 marks. That's it. Easy 3 marks. Any questions? Arham? Clear? Mohit?
Sir, clear.
Clear.
Hmm. This is one thing. Finding the angle between vectors. Angle between two lines or angle between two vectors. Next thing in vectors is simultaneously solving two equations of 3D line. We know whenever we solve simultaneously, what do we get? The point of intersection. Whenever we solve two equations simultaneously, we are working for the point of intersection. So we know how do we find the point of intersection, the simultaneous solving in the linear 2D lines, the y is equals to mx plus c, the simple ones. We do the simple substitution method, elimination method, and we get the point of intersection. Now over here, there are three cases that you need to understand that are possible when you are trying to solve two 3D lines together. So the case one, that they intersect. This is the basic one. So if you look at in 3D space, you have the x, y, z, all three, and there is a line separately going over like this, and there's another line separately going like this, and they are intersecting at one point. You will find the point of intersection, and there would only be one point of intersection. This is when they exactly intersect at one point. Second one, they are parallel. They are parallel and not overlapping. For example, your room is a 3D space. Okay, your room, it has length, breadth, and height, all three of them. So if you have a line which is going diagonal from one corner to another, and you have another line which is this is your floor. This is your floor. If you understand, this is your floor. I'm just trying to make it logical. So this is your one line which is diagonal to your floor, and there is another 3D line which is diagonal to the, what do you say this, छत को क्या बोलते हैं इंग्लिश में, व्हाट डू वी कॉल छत को इंग्लिश में क्या कहते हैं? रूफ. रूफ.
हाँ, roof.
हाँ, रूफ. So look, these two lines are parallel and they are not overlapping. So there is, you can see, no point of intersection. Third case, they are overlapping. This you won't see this much, but this is another case that is possible. So that's why I'm just giving you as an example. But you won't see this much. But Balki, you will never see this. But this is one thing that is possible, so that's why I'm giving you this thing. So let's suppose there is a line which is from one corner to another corner, like this, and there is another line also the same, overlapping. So this means in this case you have infinite number of solutions. Every point on every line, on both of the lines, is a point of intersection. So this has infinite points of intersection. You won't get a question like this, but this is a possibility. So that's why I'm just giving you as an knowledge. You may use this knowledge later on in your university. Fourth case, they are skew. Skew means that they are not intersecting, but they are not parallel as well. For example, you have one line, red one on the base, and you have another line like this. So you can see that or you have another line like this, like this. So this is on the floor. This is the corner, and this is the corner. Okay, and this is the corner. This is the corner. So you can see the two lines. They will not intersect, and they are not parallel as well. Both have different planes of movement, so they are not intersecting. No intersection, and not parallel as well. So these kinds of two lines are called skew lines. Okay, now one more thing I forgot to tell you in the case number two. When the two lines are parallel and they are not overlapping, and whenever they are parallel, their direction vectors would be same. Direction vector 1 would be k times direction vector 2. I told you, whenever there are two parallel vectors, they are scalar multiples of each other. I told you this. So the direction vector of the line 1, let's suppose this is line 1, this is line 2. They both will have the relationship between them would be a scalar multiple. Same would be over here as well. Direction vectors of the two lines will be scalar vectors of each other, scalar multiples of each other. In the fourth case, it is a bilkul separate thing. Any questions over here?
Yes, sir.
Let me show you this thing over here as well.
Yes, sir.
The point of intersection. Let's suppose this is one of the from one corner to another corner of the room. If this is a cuboid something, sorry, a cube, and from one corner to this corner, there would be a point of intersection. If this is a cube, this is actually a cube, something like that. In a cube. So you have the three dimensions x, y, and z, and you're just joining the corners together, and you will have definitely a point of intersection. So this is one point of intersection. Okay. Any questions? All good. Now
Yes,
this
sir.
concept is very important. ये चार हमने सीखे ना. They would ask you to find the point of intersection, or they will ask you to tell if the lines are parallel or not, or if they ask you to tell that the lines are skew or not. This is what they would ask you the most. Look, and the two lines I've given show that the lines are skew, or show that there is a point of intersection between the two lines. So that is something we need to now find or do a question. We have time. Yes, we have time. Now this is 3D world. I cannot make a question on my own. I don't have a very a graphic card installed in me. Very big processor. I will have to use the questions that they have given you. Okay. So they have given you, look, the lines L and M have vector equations. So L line, it is rewrite it. So this would become 1 0. Look, there's nothing. 1 0 and minus 2 plus S 2 1 3, and line M R is equals to. Now this is the thing we are learning, how to find the point of intersection. 6 minus 5 4 plus T 1 minus 2 1. And we want to find the point of intersection, so definitely we would solve them simultaneously. But before simultaneously solving them, I will just combine the two equations. Oh, sorry, simplify this thing. 1 plus 2s, 0 plus s, minus 2 plus 3s, and this is r, which is 6 plus t, minus 5 minus 2t, 4 plus t. And now we solve them, equate them together. 1 plus 2s, s minus 2 plus 3s. Look at what I'm doing. And now you would form three equations. Your equation from the first part would be 2s minus t is equals to 6 minus 1 is 5. From here will be s plus 2t is equals to minus 5. And from this one, 3s minus t, it is equals to 2 plus 4 is 6. You form these three equations. Equation 1, equation 2, equation 3. Now choose any two of the equations and solve them simultaneously. It's up to you. You can choose the first and third, second or third, first or second. It's up to you. So I am choosing right now. I'll use the calculator, okay? I want to save time. So I am choosing equation number 1 and equation number 2. And I'll use the calculator. So equation number 1 is 2 minus 1 and 5. And equation number 2 is 1, 2 and minus 5. So you are getting your value of s. S is coming out as 1 and t is coming out as minus 3. Now is the important part. You use any two equations and you solve for the two variables. And now you see if the check if the third also satisfies these values. So the third equation is 3 times s is 1 minus minus 3 is equals to 6. So it is coming out as 3 plus 3 is 6. 6 is equals to 6. So yes, it is satisfying. And when it is satisfying, they are intersecting. There is a point of intersection. You can find it. If the third equation does not satisfy, then this will tell you that the two lines are skew. There is no point of intersection. But if the third equation is also satisfied, then you would have a point of intersection. Right now, yes, they are intersect. It is satisfying. So yes, there is a point of intersection. Otherwise, if not, if not satisfying the third one, then it would be skew. So in this case, it is satisfying. And then they're asking you to find the position vector as well for the point of intersection. So now you can use any one of them, s1 or t minus 3, and substitute over there or here and find the value of r. So now this would become the point of intersection would be now equal to 1 plus 2 times s is 1, and minus 2 plus 3 times 1, which will come out as 3, 1, 1. This is your answer. This is the point of intersection. Okay, copy this down. Everything right now is important. Okay, so now you know this as well. There's only one more thing left now to discuss. Show that line. Okay, let's do this one as well. Do not intersect. Do not intersect means that the lines are skew. So we would do the complete same thing, and at this step, we will see that the equation, that the two values that we are getting will not satisfy the third equation, and that will show that they are not intersecting. So the equation 1 is 2 plus s minus 1 plus s, and 4 minus s, and line 2 minus 2 minus 2t, 2 plus t, and 1 plus t. Okay, I have just taken the x from here and x from here, y from here and y from here, z from here and z from here. And now you will solve them simultaneously. You will equate each other together. So 2 plus s minus 1 plus s, 4 minus s, minus 2t, 2 plus t, 1 plus t. And you would form the three equations. So this would become s plus 2t is equals to minus 2 minus 2 minus 4, s minus t, 2 plus 1 is 3, then minus s minus t, it is equals to 1 minus 4 is minus 3. So use equation 1 and equation 2, let's suppose. Using equation 1 and equation 2, your values of s and t are coming out as, let's see, 1, 2 minus 4, 1 minus 1 and 3. So s is 2 upon 3 and t is minus 7 upon 3. And if you put this thing in the third equation, so minus 2 upon 3 minus 7 upon 3, is it equal to negative 3? I don't think so. Minus 2 upon 3 plus 7 upon 3. So 5 upon 3. So look, 5 upon 3 is not equal to minus 3. So therefore, it is skew. There is no point of intersection. If the third one is also satisfied, then they are intersecting fully. Now this is a little bit interesting. They will ask you to find the perpendicular distance from a point to a line. Sorry. I said 2 in my mind, but I did not write it down. Okay, so this is your 3D line, let's suppose. Line 1. And they have given you a position vector, external position vector, OX. This is the position vector. And what are they asking you? They are asking you to get the perpendicular distance between the line and the this, what do you say,
Vector. Like,
and the point between the
okay.
line and the.
Okay.
So this is the interesting thing. Now one more thing I forgot to tell you, that when two vectors are perpendicular, when two vectors are perpendicular, so their dot product comes out as 0 always. Why? Because your formula is what? Your formula is A dot B is equals to A magnitude B magnitude and cos theta. And if your theta is 90, perpendicular means that the angle between the vector is, if it is 90. So if the vectors are perpendicular, so cos 90 is 0. Look, we know cos 90 is 0. So cos 90 is 0. So this means that this complete thing becomes 0. So you are left off with the dot product being equal to 0. समझ आया? Now we will use this logic to find the perpendicular distance between a line and an external point. So what do we do? I think we'll have to do it very quickly, only 10 minutes left. So this is the arbitrary point on this line, which we don't know. This will be, let's you can call it, let's change the name. You can call it OX. So this point OX, you can write it down in terms of your parameter. In terms of parameter, you can parameter your S or lambda, whatever it is, you can write it down. And then you can find the vector AX. AX will be this vector. And AX will be equal to OX minus OA. So you have the OA, they have already given you the point, external point OA. And you will find the OX, the point OX, in terms of the parameter. It is a general term of OX. And then this AX, you can see this vector AX will be perpendicular to direction vector of the line. So this means that AX dot product with the direction vector of the line will be equal to 0, because when two vectors are perpendicular, their dot product is 0. And then there you would find, using this, find the parameter, find the value of the parameter when this happens. And then you can use this value of parameter to get the point of x or AX, and then you find the distance. Perpendicular distance would be this AX magnitude. So if you have the value of the parameter, that when this is happening, you will substitute it over there and you will find the vector AX, and then you will find the magnitude of the vector AX. That would give you the perpendicular distance between the external point and a line. This is the background. These are the steps that you would follow. Sorry?
यार ठीक हो गया.
Hmm. So this is your first step. This is your second step. Third step. Fourth step. And then fifth step. Okay. Let's do one question. So look, they have given you a point, external point, minus 1, 4, 11, and they have given you the equation of a line. and they're asking you to get the perpendicular distance between from P, the external point, to the line L. So this is your straight line, and this is your external point P. OP is given to you. So first you will find the this point OX in terms of the parameter. So R, it is equals to 1 plus 2 lambda, 3 plus lambda, and minus 4 plus 3 lambda. And therefore, in terms of this lambda, I can find the point of intersection between the perpendicular dropped from the P to the line. It will be the same 1 plus 2 lambda, 3 plus lambda, and minus 4 plus 3 lambda. Generalized coordinate for this point. Now we can find Px. Px will be Ox minus OP. So Ox we have found 1 plus 2 lambda, 3 plus lambda, minus 4 plus 3 lambda. Minus OP. They gave us OP. Minus 1, 4, 11. And if you simplify, you will get minus 1 minus 1 would be 2. 2 plus 2 lambda. 3 minus 4 minus 1 plus lambda. And minus 4 minus 11 minus 15 plus 3 lambda. Now this vector px with the dot of the direction vector of line. So this is your px and dot with the direction vector of line. The direction vector of line is this, the part with the parameter 2, 1, 3. And because these two are perpendicular, the line, the px and the line, this would equal to 0. And you would solve it. 2 times 2 plus 2 lambda. So 4 plus 4 lambda plus minus 1 plus lambda plus minus 45 plus 9 lambda is equals to 0. And you can solve this, find the value of lambda. So minus 4 plus 1 plus 9 would become 14 lambda. And 4 minus 1 minus 45 minus 42 is equals to 0. And therefore your lambda comes out as 42 upon 14, 3. So now you know the value of lambda. So if you use the value of lambda over here, you will get the equation of px. Sorry, you will get the vector px. So 2 plus 6 is 8, minus 1 plus 3, 2, and minus 15 plus 9, minus 6. This is your px vector. And the perpendicular distance would be this vector px का magnitude, which will be equal to under root 8 square plus 4 plus 36. So 210.20. This is your answer.
ओके, ठीक हो गया.
Okay, I'm stopping the recording. This is it for today's class. In the next class, we'll just do past papers of this further.